All right, this is 2021 FRQ number 3, and from this point on, you are in the non-calculator section, so we're going to do all these problems by hand, okay? All right, a company designs spinning toys using the family of functions y equals c, c times x square root of 4 minus x squared, where c is a positive constant. The figure above shows the design of the first quadrant bounded by the x-axis and the graph of y equals c x times root c 4 minus x squared for some c. Each spinning toy is in the shape of a solid generated when such a region is revolved around about an x-axis. Both x and y are measured in inches. So it's going to revolve around the x-axis like this. So it's kind of a top looking like thing. Okay, so just have an idea what that looks like. Okay, all right, so find the area of the region in the first quadrant bounded by the x-axis and the graph of this function for c equals 6. So first of all, you want to find where this intersect is, right? You know this is 0. Where does it intersect here? So for part A, I need to find the intersection. So I simply take my equation, y equals cx root 4 minus x squared set equal to 0. So you get 0 equals cx. That doesn't tell me anything. Then 0 equals square root of 4 minus x squared. That gives me 0 equals 4 minus x squared. X squared equals 4. Technically, x equals plus or minus 2. However, since we're only in the positive quadrant, x equals 2. So I know then that is 2 comma 0. That is going to be my second intersection. Okay, so the area of this, right, the area of this region, first it says find the area of the first quadrant. Okay, so then c equals 6. So area equals integral 0 to 2. My function of 6x root 4 minus x squared. Okay, so you can see this is going to be a U-sub problem because you have 4 minus x squared in my square root and you have an x on the outside. Pull the 6 out because 6 is a coefficient, right? So I'm going to have 6 here, and then here I'm going to use my U-sub and say, right, u equals 4 minus x squared, du equals negative 2x dx, negative 1/2 du equals x dx. And I'm also going to change my interval because that way it makes a nice U-sub here. So u of 2 equals 4 minus 4, that gives me 0. U of 0 equals 4 minus 0, gives me 4. Okay, so it's going to switch that around like so. And you're going to have times negative 1/2, right, du, and then u to the 1/2 power. Okay, so now what this does is I'm going to make this 3, and that negative is going to make me change it back 0 to 4. U to the 1/2 du. Okay, now I have 3 u to the 3/2 times 2/3, 0 to 4. These reduce out. I get 2. 4 to the 3/2 is really 2 squared to 3/2. So 2 squared to 3/2 minus 0, so it doesn't really matter what that 0 is. So it gives me 2 times 8. That gives me 16. So this is the area for this shape if c equals 6. Okay. All right. Moving on. It is known that for y equals c for this function, the dy dx equals this function for a particular spinning toy. The radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for this spinning toy? So key word is the word largest, right? Largest typically means we are trying to maximize something. When we want to maximize something, we set the y derivative, the y prime equals 0. So we have a y prime already. We don't need to solve for it. Y prime is here already. Set that equal to 0. Notice you have your numerator and your denominator. In order for it to truly equal 0, your numerator has to equal 0. You don't care about the denominator. So you simply take this and say, all right, 0 equals c times 4 minus 2x squared. So 0 equals c, right? That could be one answer, but that doesn't help me. If c is 0, then there's no shape here, so that's not helpful. So 0 equals 4 minus 2x squared. 2x squared equals 4. X squared equals 2. X equals plus or minus 2, plus or minus root 2. Oops, sorry. All right, equals plus or minus root 2. But because we're in the first quadrant again, we're literally looking for x equals root 2, positive root 2. Okay, so what is the value of c for this spinning toy? So what you want to do now is you're going to go ahead and plug back into your function here. So we have root 2 right here. So we're trying to find my equation here. Okay. All right. So the radius of the largest spinning, the radius of the largest cross-sectional slice is 1.2 inches. So the radius, that's your y value, right? So your y value is going to be 1.2 inches. So you're going to plug everything you know, because think about it, your radius is going out this way, right? So that's your y value. So the biggest radius is 1.2. So you get 1.2 equals cx. I don't know what c is. That's what I'm trying to solve for. Why does it keep erasing for me? So let's try this again. Part B down here says 1.2 equals c times x. X is root 2. Square root of 4 minus root 2 squared. So you get 1.2 equals root 2 times c times root 4 minus root 2 squared. So 4 minus 2, that's root 2 again. So 1.2 equals 2c. C equals 0.6. All right, so that's my final answer for part B. Okay, for part C. For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? So we're going to spin this, right? If I spin this and I go this way, this is my dx function. So this is a disk function, not a washer, because there's no gap in the middle. So the volume of this, is going to be pi 0 to 2 pi r squared. My radius is my y function, so cx root 4 minus x squared dx, right? So you're going to solve for this first and then set this equal to 2 pi, because I know that that's my volume I want, and I'm going to use that to solve for my c. Okay. First things first, I can actually get rid of the pi first, because that actually makes it so much easier for me. So I get rid of the pi. Okay. Now I'm going to clean this up a bit before I take the integral. So that's c squared x squared, right? And you have your square root of 4 minus x squared, so times 4 minus x squared dx, right, equals 2. Okay, so remember c is your coefficient, so you can take it outside. So c squared integral 0 to 2. I'm going to multiply this out. So 4x squared minus x to the 4th dx, so go to 2. So you have c squared. Now take the antiderivative. 4x cubed over 3 minus x to the 5 over 5, 0 to 2. So then you multiply that out. So you get 4 times 8 is 32 over 3 minus 32 over 5 minus 0 is 0. So I get 2 equals c squared. That gives me 64 over 15. All right, so multiply it over. I get 30 over 64 equals c squared. So c must equal to plus or minus 30 over 64. Right, so you can reduce that. There's a couple ways to reduce this. You can reduce it and just get c equals, because c is a positive value. A negative value wouldn't give me the same curve here. So c is going to be square root of 15 over 32, or you can say square root 30 over 8. That works. So either way works. Either way is your answer. Okay.